Bismillahirrahmanirrahim. In this session, we will discuss exercise 14.4 for additional mathematics course for IGCSE and O level students. In this session, we will discuss the normal on a curve and a tangent on a curve with some certain points and related areas. So we will discuss these kinds of problems. So let's start this question number 2. A curve has the equation y is equal to x sine 2x. This is a curve x times sine 2x for the period of 0 to pi, and find the equation of normal to the curve at the point p pi by 4 and pi by 4. So this is the vertices. At this point we have to find the equation of normal. So for the equation of normal we have to find the gradient, and on that gradient we have to find the gradient of the normal, and then that is the reciprocal minus inverse, and then we will find the normal equation of normal. And after that, the normal at the P intersection, the x-axis at Q. So the normal at P intersect x-axis. So that normal equation intersect the x-axis at P, at Q it intersect, the normal at P intersect the x-axis, and at Q and y-axis at R. So that this normal intersect the x-axis at Q, at point Q, where x-axis intersects, so y is 0 at this point. Similarly for y-axis at R, so at this axis x value is 0, so 0 and some value of y. So find the coordinates of Q and R. So we have to find the coordinates of this Q and R. And in the last section, find the area of the triangle OQR, where O is the origin. So this is very important question. We have given a curve and we have to find the equation of normal on this curve with reference to this point. So let's start this. This is 14.1 and we have to solve this. So we have been given this curve y is equal to x sine 2x for the period 0 to pi, and the equation of normal at the curve at point P pi by 4 pi by 4. So let's find the dy by dx, that the gradient. So for this is u and this is v. So u we applied, and dy by dx has obtained as 2x cos 2x plus sine 2x. And for this we have to find this dy by dx at pi by 4 pi by 4. So for x value pi by 4 we place it here, and we have obtained dy by dx is equal to 1. So dy by dx has obtained as this. So for this value y, we will place this pi by 4 here, pi by 4. So the y value is obtained as pi by 4. So y1 is pi by 4 and x1 is also pi by 4. So this is pi by 4, this is pi by 4, and this intercept is 1. So the gradient of the normal would be minus 1. So 1 into minus 1 will be, resultant will be minus 1. So this is minus 1. So in that case this is 1 for this. So this becomes minus 1. So this is the required. We'll change it here and shift it here. X plus y is equal to pi by 2. So this is multiply here, 2x plus 2y is equal to y. So this is the equation of normal on this curve at this point. This is a part 1. And in a second part, 2x plus 2y is the normal equation, and from this normal equation intersect x-axis at this Q point. So at this Q point we have some x value and y value is 0. So y is 0, so x is equal to pi by 2. So this coordinate of Q is obtained as pi by 2 comma 0. For similarly for this equation at R has x value 0. So this is x value 0 for R, and we have this y value, and this is pi by 2. So 0 pi by 2 is again. So this is OQR. O is the origin, Q and R the area. So we have to find the area of the triangle. So OQR is a triangle. So this is origin value, this is Q value, this is R value, and then again it repeats. So this multiplies, so this multiplies, this multiplies, this multiplies, so all 0, so it multiplies, it multiplies. So this is only pi square upon 4. So this is half, and pi square upon 4, which is pi square upon 8. This is the answer. So this is very important question. This kind of questions are asked in final exams. So this was question number 2. Let's solve question number 5. A curve has the equation y is equal to x e power x. The tangent to the curve at the point 1 comma e meets the y-axis at point A. A tangent to the curve, a tangent, a gradient, a line of equation on this curve y is equal to x e power x at the point P1 comma E meets the y-axis. That tangent meets the curve at the point P1 comma E meets the y-axis at point A. The normal to the curve at P, at this point P, meets the x-axis at point B, meets the x-axis where the y value is 0 at point B. Find the area of the triangle OAB where O is the origin. So let's ask question number 5. So here we have y is equal to e power x, tangent to the curve at point this meets the y-axis at point A. So take the gradient of this, so y upon dy upon dx is equal to this u and v, and we have obtained dy by dx is this, and at point P we have to find this gradient. So at point P we will place this 1, x value is 1, so 1, so we will place this 1 1 1, so it becomes 2e. So 2e is the gradient of this, or the tangent on this curve. So this tangent is obtained. So equation of tangent becomes y is equal to y1 minus xm, x minus x1, and this is x1, this is y1. So this is y1 and this is x1, and this is gradient or tangent, so y minus c. So from this we have this equation, and this is equation of tangent at this curve, at point P. So we have obtained this tangent, equation of tangent at point P, and now this equation at point A meets y-axis. At y-axis means x is equal to 0. So at x is equal to 0, point A will be obtained. So this is 0, so this becomes y is equal to minus e. So the A point is 0 comma minus e, and the normal equation, normal to the curve intersect at point B. So the equation of normal, so for equation of normal we have this y minus ye 1 x, and for this 1 over m is given as here 2e, so it becomes minus 1 over 2e. Minus 1 over 2e is the, this is the gradient of normal equation. So this is a normal equation, and this meets at point B, meets y-axis. So y-axis, x-axis, sorry, x-axis. So at this x-axis y is 0. So this y becomes 0, and we will obtain the x value. So for this y is equal to 0, and this is minus e, 1 over e, and this. So this is minus minus cancel, and this is multiply here. 2e square is equal to x minus 1, and x is equal to 1 plus 2e square. So this b is 1 plus 2e square comma 0. So this is 0 0 o a b, and this is a, and this is b, and this is. So we see this this multiply with this multiply with this multiply with this. So this multiply with this, we will have this value. So this is always positive because this is an area, and area is always comes in a positive. So this is 1 half e 2e square minus plus 1, 2e square plus 1. So this is the result of this problem number 5. Now solve question number let's solve question number 10. A curve has equation y is equal to ln x square minus 2 upon x square minus 2. Find the appropriate change in y. Change in y as x increases from under root 3 to under root 3 plus p, where p is small. So we have to find this. Actually the print is not available. So a similar kind of problem is in problem number 8. We can solve it. We have this. Let's see the question number 8 here first. Variable x and y are connected by the equation this, and appropriate change in y as x increases from 1 to 1 plus b. So this is small change in y. We have to approximate the change in y when x changes from 1 to 1 plus b. So this is a small change in y. The x is small change in x is b, and we have to see the effect on y, small change in y. So this is question number 8. This is question number 8. So we have this y is equal to ln x plus 3. So this is dy by dx is obtained as this. So this is u and this is v, and u upon v, we have applied this u upon v differentials, and on simplification at x is equal to 1, because the x initially the x value is 1. So this is obtained as 1 upon 4, and this is a delta x, delta y, delta x is equal to dy by dx, and dy by dx is obtained as 1 upon 4. So this is 1 upon 4, and we have this change is p. So the change in y is appear as 1 over 4p. So p upon 4, delta y is p upon 4. For a small change in y, x is p, and the small change in y appear as p by 4. So question number 8, and let's move to question number Let's move to question number 12.